With AI constantly popping up in more and more places, it can feel like we're trying to map a territory that's, well, still being formed. There's so much news, so many developments. It's easy to feel like you're missing something crucial.
That's absolutely right. And that's why we wanted to do a deep dive into something pretty fundamental for navigating this rapidly changing landscape, AI governance. Think of it as establishing the guardrails for this powerful technology.
Exactly. We're going to unpack the core questions. Why do we even need to govern AI? What does that actually look like? How do we, put it into practice? Who needs to be involved? And when should all this happen? We've gone through a whole stack of really detailed stuff, international standards, technical reports, all about AI to pull out the vital insights for you.
Yeah, distillation is key here.
Right. Our goal is to give you a clear, understandable overview, save you the time of sifting through it all yourself, and hopefully give you some of those aha moments along the way.
And what's really valuable about these standards, I think, is that they move beyond just, theoretical discussions. They offer concrete principles and techniques that organizations can use right now to manage their AI systems responsibly.
Okay, so let's tackle the fundamental question first. Why is AI governance so critical right now? Why the urgency?
Well, consider this. AI systems are becoming increasingly complex. They can react to unexpected data in ways we didn't foresee, maybe couldn't even imagine.
Right.
And even subtle changes in the information they're fed, things called adversarial examples, can lead to drastically different outcomes. It's not always a straightforward cause and effect like, say, traditional software.
Right. It's not like your calculator where 2 + 2 always equals 4.
Yeah.
With AI, because it learns from data, the rules aren't always explicitly programmed, which introduces a degree of unpredictability.
Precisely. This inherent complexity makes it much harder to guarantee that AI systems will consistently behave as intended. The traditional methods we use to verify regular software, while still important, often aren't enough on their own to address the nuances that come from training data and these less predictable outputs.
So how do we get a handle on this then? Do we just sort of cross our fingers and hope for the best?
Not at all, no. This is where verification and validation, or V&V, comes into play as a really vital addition to the standard testing for AI.
V&V, okay.
Yeah, V&V gives us a more thorough way to assess if these systems are performing as they should and whether they're reliable. It includes a range of powerful techniques, from using mathematical proofs to simulating real-world scenarios and rigorously evaluating their performance.
Mathematical proofs for AI. That sounds pretty advanced. Can you give us a glimpse into what that means?
Sure. These are what we call formal methods. Basically, they use mathematical models and logical reasoning to verify that an AI system is built according to its design specifications. So instead of just running tests, we're essentially using math to prove certain properties about the system. Think of it maybe like proving a theorem in geometry. Examples include runtime monitoring, where the system is constantly checked against predefined rules as it operates.
While it's running.
Yeah. Then there's model checking, which systematically explores all possible states of a simplified version of the system to ensure it meets requirements. And theorem proving, which uses logical deduction to demonstrate the system's correctness.
Wow, so instead of just seeing if the bridge collapses under load, you're trying to mathematically prove its design won't allow it to collapse under specific conditions. That's a powerful level of assurance for critical AI.
Exactly. The real strength of formal methods is their ability to uncover potential issues in scenarios that traditional testing might completely miss. For example, deep neural networks, those really complex systems behind a lot of modern AI, they can be represented as intricate networks or graphs, and their behavior can be translated into mathematical constraints that could then be formally analyzed.
That's mind-blowing, but it also sounds incredibly complex to set up, is it?
It certainly can be. One significant challenge is actually defining the intended behavior of a complex AI system in precise mathematical terms. What exactly should the output be for every possible input? That's tough.
Yeah, I can imagine.
Another hurdle is what's known as the state space explosion, where the sheer number of possible states a system can be in becomes astronomically large, making it computationally very, very difficult to analyze them all.
So too many possibilities to check.
Essentially, yes. Researchers use techniques like abstraction to simplify these models. For instance, there's something called ANET, which is a specific model checking approach designed for analyzing neural networks, specifically to understand their resilience to noisy or slightly corrupted data.
Okay, so formal methods are one piece of the puzzle, a complex piece. You also mentioned simulation. How does that help us govern AI?
Right, simulation. It allows us to create virtual environments that mimic real-world situations. This is incredibly valuable for testing an AI system's accuracy, reliability, and robustness before it's deployed in the real world, where, mistakes could have serious consequences.
Makes sense.
We can subject these virtual systems to a huge variety of conditions, including rare or extreme edge cases that would be difficult or even dangerous to test in reality.
So it's like a digital sandbox where you can throw all sorts of challenges at the AI without any real-world repercussions, like a flight simulator for AI.
Precisely.
Yeah.
Exactly like that. We can carefully control and manipulate different variables within the simulation to see exactly how the AI responds under specific conditions. And simulation isn't just for the final testing phase either.
I mean,
No, it can be used throughout the entire AI lifecycle, right from the initial planning stages through design and even into ongoing monitoring after deployment. The idea of digital twins takes us a step further, where a virtual model is continuously updated with real-world data, allowing for continuous validation of complex AI-driven physical systems.
that makes perfect sense, especially for things like self-driving cars or, I don't know, robotic surgery, where you just can't ethically or practically test every conceivable scenario in the real world. But how do you ensure the simulation itself is, a good enough representation of reality? Isn't that a challenge?
That's a critical question, absolutely. Yeah. There's always a balance to be struck between the level of detail and accuracy in the simulation, the fidelity, and how quickly it can be run and analyzed. More detail means slower simulations.
Right. The trade-off.
Exactly. Techniques like adversarial methods can also be used within simulations to automatically generate challenging or unexpected scenarios that the AI might struggle with. This helps us to focus our testing efforts on the most critical areas, the potential weak spots. Got it. All right, we've got the mathematical rigor of formal methods and the virtual testing ground of simulation. The last piece of V&V you mentioned was evaluation. What does that entail?
Evaluation involves using a range of methods to assess the overall quality and performance of AI systems. This often draws upon established frameworks like the Square Quality Model, which is referenced in ISO IE 25058.
Square.
Yeah, it stands for Software Product Quality Requirements and Evaluation. It provides a model for quality characteristics. So examples of evaluation techniques within V&V include cross-validation,
Okay, I've heard of that.
right, which helps us ensure the model performs well on new, unseen data, not just the data it was trained on. There's also hyperparameter tuning validation, which optimizes the model's internal settings, the knobs and dials, so to speak.
Then performance benchmarking, where we compare the AI's speed, accuracy, and resource usage against specific goals or maybe other AI systems. And finally, things like confusion matrix analysis, which gives us a detailed breakdown of a model's classification performance, what it gets right, what it gets wrong, and how it gets things wrong.
So evaluation is about putting measurable metrics to the AI's capabilities and seeing if it actually meets the required standards of quality and performance we set out.
Exactly. And it's crucial to remember that AI systems don't operate in a vacuum. They're often integrated into complex environments with human users, other software, other systems.
Right.
This interconnectedness really underscores why AI governance is so vital for ensuring responsible and effective deployment. We need to think about the AI not just as a standalone piece of technology, but as part of a larger system, often a socio-technical system.
And this is where it links back to the idea of managing risk at a broader organizational level, right? Not just the tech risk.
Absolutely. AI governance is deeply embedded within overall organizational risk management. Standards like ISO IEC 23894 specifically outline the principles of managing risks associated with AI and how these principles should be integrated into broader corporate governance frameworks, such as ISO 38507.
Okay.
A key aspect here is the commitment from leadership top management to prioritize responsible AI practices and to effectively communicate potential AI-related risks to all relevant parties, stakeholders.
So it's not just a technical exercise for the engineers. It really requires buy-in and clear communication right from the top levels of an organization.
Precisely. Organizations need to have a clear understanding of both what's happening outside the organization, the evolving regulations, the expectations of customers, and the public, the external context, and what's happening inside their own goals, policies, culture, and the resources they have available for AI development and deployment. That's the internal context. And, the increasing complexity of AI also means that organizations really need to invest in specialized training for their teams. It's not just business as usual.
And why is a risk-based approach particularly important when it comes to AI, more so than regular software?
Because AI introduces novel and often unpredictable risks, as we discussed. A risk-based approach allows organizations to systematically identify, assess, and then put in place measures controls to address these potential risks at every level. That means from the overarching strategy down to the individual AI project where the technology is actually being built and used. It helps prioritize effort.
Okay, we've got a good handle on why AI governance is essential. Now, let's dig into the what. What exactly is AI governance in a practical sense? What are the components?
At its heart, AI governance is the comprehensive framework, think rules, practices, processes, that guide the responsible development and deployment of AI systems.
The framework. Okay.
Yeah, it's the overarching structure that ensures we are creating and using AI in a way that aligns with our ethical values, our legal obligations, and our strategic goals, while actively minimizing potential negative impacts.
Within this framework, the V&D analysis we've been discussing, formal methods, simulation, evaluation, that's a core set of tools and techniques, right?
Absolutely. Those V&V elements are key technical components within the governance framework. They help us to ensure the reliability, safety, robustness, and effectiveness of AI systems, which are all, crucial aspects of good governance.
Okay, so now that we know the why and the what, let's move on to the how. How does an organization actually implement AI governance in practice? What are the nuts and bolts?
Well, effective implementation relies heavily on a well-defined AI risk management process. And as we mentioned, ISO IEC 223894 provides a detailed blueprint for this.
The risk management
Yeah,
process.
right. The process begins with clear communication and consultation with all stakeholders, anyone who might be affected by the AI system. It's really essential to define the scope of the AI project clearly, the context in which it will operate, and the specific criteria we will use to evaluate and manage the risks identified.
Engaging stakeholders sounds crucial. Who exactly falls into that category? I know you said you'd come back to it.
Yeah, we'll delve more into the who specifically in a moment, but for now, think really broadly. Anyone who has an interest in or can be impacted by the AI system. This includes the developers, obviously, the end users, customers, regulatory bodies, and even the wider community or society.
Okay, so open communication, broad consultation is step one. What follows in this risk management process?
Next comes the risk assessment itself. This involves systematically identifying potential sources of risk, what could cause harm. Then the specific events that could occur as a result, then the potential consequences if those events happen, and finally, estimating the likelihood of those consequences.
Identifying, analyzing, evaluating risk.
Exactly. And it's really important here to consider the impact not just on the organization itself, but also on individuals, on specific communities, and society at large. We need to be particularly aware of situations where the benefits of an AI system might accrue to one group, while the potential negative consequences are disproportionately borne by another.
That's a really insightful point. The distribution of benefits and risks can be uneven and definitely needs careful consideration. That feels like a key ethical dimension.
It absolutely is. So once we've assessed the risks, we move to risk evaluation and treatment. This involves deciding which risks are acceptable as they are, which need treatment, and then selecting and implementing appropriate strategies, controls to reduce the negative consequences and maybe even enhance potential positive outcomes.
Okay.
A thorough risk-benefit analysis is essential at this stage to understand the residual risks, the risks that remain even after these treatments have been applied. Is that remaining risk acceptable?
So it's an ongoing cycle of identifying, understanding, treating, and then reevaluating the remaining risk.
Precisely. And the final stages of the risk management process involve continuous monitoring and review. We need to watch the identified risks, check the effectiveness of our mitigation strategies, and crucially, document and report all risk management activities.
Document everything.
Yes. This ensures that our understanding of the risks stays current as the AI system inevitably evolves and as the environment it operates in changes over time.
And where does an overarching AI policy fit into this framework? You mentioned that earlier.
Right, the AI policy. As described in ISO FPIS 42001, that's a foundational management system standard for AI, the policy is a formal document established by the highest levels of management within an organization, top management commitment.
Got it.
It should align with the organization's overall mission and strategic objectives and provide clear, high-level direction for the responsible development and use of AI across the board.
So it sets the tone from the top.
Exactly. And the AI risk assessment process we just discussed should be directly guided by this AI policy and the organization's specific AI-related goals or objectives. The risk assessment process also needs to be designed to produce consistent and comparable results over time, and it should explicitly consider relevant safeguards and controls. Annex A of that 42001 standard actually provides a pretty comprehensive list of potential controls organizations can consider.
Okay. You also mentioned something called an AI system impact assessment. What's the purpose of that? How's it different from the risk assessment?
Good question. The AI System Impact Assessment, also detailed in FDI's 42001, is a specific process focused on evaluating the potential effects, both positive and negative, that the deployment and intended use of a particular AI system could have specifically on individuals and society.
Focus on people and society.
Right. It takes into account the specific technical characteristics of the AI system and the broader societal context in which it will be used, including potential for misuse or unintended consequences. These impact assessments should ideally be conducted regularly and definitely when significant changes are planned for the AI system. And again, the findings need to be thoroughly documented.
Okay, so those are some of the overarching processes: risk management, policy, impact assessment. What about more specific techniques that fall under the V&V umbrella and contribute to good AI governance on the ground?
Sure, there are several important techniques worth highlighting. One is calibration error measurement and recalibration.
Calibration error.
Yeah. Calibration in this context refers to how well the confidence level that a model predicts for its output actually aligns with its real-world accuracy.
Okay. Explain that a bit more.
So, for example, if a classification model says it's 90% confident in a particular prediction, is it actually correct about 90% of the time when it makes predictions with that level of confidence? Or is it overconfident or underconfident?
I see. Is its confidence justified?
Exactly. Metrics like expected calibration error, ECE, and maximum calibration error, MCE, help us quantify this potential misalignment. And for classification models that are found to be poorly calibrated, various statistical methods can be applied during the V&V process to essentially recalibrate them, making their confidence estimates more reliable and trustworthy.
So it's about ensuring the AI doesn't constantly overestimate or underestimate how sure it is about its decisions. That seems important for trust.
Definitely. Another critical area is explainability evaluation, often abbreviated as XAI.
XAI, explainable AI. Heard a lot about that.
Right. Being able to quantitatively evaluate how well an AI model can explain its decisions or how well we can interpret its workings is crucial for building trust in the system and also for facilitating thorough verification. We need to know why it made a decision, not just what decision it made.
How do you measure explainability?
Well, we use various metrics. There are perturbation-based metrics, which examine how small changes in the input data affect the model's output and its explanation. There are also saliency-based metrics, which try to highlight the importance of different input features in the model's decision-making process.
Like heat maps showing what part of an image the AI focused on.
Exactly. That's a type of saliency visualization. Techniques like gradient-based attribution and layer-wise relevance propagation fall into this category of generating explanations. Then we also have fidelity metrics, which assess how accurately an explanation actually reflects the real reasoning of the model, rather than just being a plausible story.
So the explanation itself needs checking.
Yes. And there's even human-in-the-loop fidelity, which measures how well humans can actually understand and trust the explanations provided by the AI, and whether those explanations help them make better decisions or perform tasks more effectively.
So it's not enough for the AI to be correct or even explainable to experts. We also need to understand why it's correct or why it made a particular decision, and that understanding needs to be accessible and meaningful to the people using or affected by it.
Precisely. Makes explanations useful. Finally, benchmarking is another essential technique. It involves evaluating an AI system's performance, including aspects like speed, accuracy, resource consumption, robustness, fairness, and maybe adherence to relevant regulations against predefined goals, and often in comparison to other AI systems or established baselines.
Comparing apples to apples, or at least trying to.
Kinda, yeah. There are various types of benchmarks depending on the complexity of the task, the variability of the data used, and the required response time. You might have heard of examples like MLPerf inference or AI benchmark. These are well-known efforts to create standardized AI benchmarks.
Okay, so benchmarking provides an objective way to measure and compare AI systems, helping us ensure they meet certain performance thresholds and understand how they stack up.
Exactly. Now let's move on to the who. Who is actually involved in making AI governance a reality within an organization? It's certainly not just the technical teams locked away in a lab, is it?
Absolutely not. As we touched on earlier when discussing stakeholders, effective AI governance requires the involvement of a wide range of individuals and groups, right?
Indeed. And right at the very top, we have the absolutely crucial role of top management. As highlighted clearly in ISO ITI FDIS 42001, their responsibility includes establishing the organization's AI policy, demonstrating clear leadership commitment to responsible AI practices, and importantly, fostering a culture where these principles are understood and followed throughout the entire organization.
Their support and active involvement really set the tone and priorities for everyone else. Without that, it's probably just performative.
Exactly. It has to be genuine. Then, of course, we have the AI developers, the data scientists, the machine learning engineers, the people who are directly responsible for designing, building, testing, and deploying the AI systems. They're the ones implementing the V&V techniques and adhering to the established governance frameworks day to day.
They are the ones on the ground, translating the governance principles into technical practice, into code and models.
And it's not just them working in isolation. Domain experts, people who have deep knowledge in the specific area where the AI is being applied, like healthcare, finance, or manufacturing, they play a vital role.
How so?
They provide crucial context. They help define the specific requirements for the AI system based on real-world needs, and they help establish the criteria for determining if it's performing acceptably in that specific domain. They know what good looks like in their field.
Right, they bring the essential real-world understanding of the problem the AI is trying to solve and what constitutes a successful or safe solution in that context.
Correct. And then we must also actively consider the needs and expectations of all the various other interested parties, the end users who interact directly with the AI, the customers whose lives might be affected by its decisions, regulatory bodies that set the legal and compliance boundaries, and the general public who have a stake in the broader ethical and societal implications of AI deployment.
That's a wide net.
It is. Standards like ISO IAC FDIS 42001 and also ISO IAC 22989 on AI concepts and terminology emphasize the importance of considering these diverse perspectives throughout the entire AI lifecycle, not just at the end.
So it truly is a collaborative effort. It spans across technical teams, business leaders, domain specialists, legal and compliance folks, ethicists, and requires consideration of the broader societal landscape.
Absolutely. Effective AI governance hinges on strong collaboration and open, ongoing communication among all these diverse stakeholders. It can't succeed in silos.
Okay, makes sense. Finally, let's discuss the when. When should AI governance be applied? Is it something that happens like right at the end once the AI system is fully developed and ready to ship?
Definitely not. That would be far too late. AI governance isn't a one-time checklist item you tick off before launch. It needs to be an ongoing and iterative process that is applied continuously throughout the entire life cycle of an AI system.
Continuously, okay.
Yeah, think about Figure 2 in ISO ATS 17847 on V&V for AI. It visually illustrates this continuous application, this loop, at each stage of AI system development and deployment.
So it's integrated right from the initial idea, the concept phase, all the way through to when the AI is being used in production, and even beyond that, when it's eventually retired.
Precisely. For example, V&V analysis, a core part of governance, can and should begin as early as the initial project planning and scoping phase.
Yeah.
What are we trying to build? What are the potential risks? Even at this early stage. It then continues intensely through the design and development stages, where AI models are actually being trained, tested, and refined iteratively. Then, crucially, during the deployment and ongoing monitoring of the AI system in the real world, V&V plays a critical role in continuous validation and reevaluation. Is it still behaving as expected?
And the results of that ongoing V&V might feed back into earlier stages.
Exactly. The results might trigger a return to earlier phases like design or development for further refinement, retraining, or adding new controls. It's a loop. And as we discussed earlier, different techniques might be more prominent at different stages. Formal methods might be most useful in the early design stages to verify core properties, while simulation becomes more relevant once a working prototype or model has been developed.
And what about after the AI system has been deployed and is actively being used? Does governance stop there?
No, absolutely not. Even after deployment, continuous monitoring of the AI system and its environment is crucial. The world changes. The data it sees might drift over time. Data drift. The environment it operates in can change. New vulnerabilities might be discovered. Software updates might be applied to the system or components it interacts with.
Right.
All of these things can potentially impact the validity of our initial V&V findings and risk assessments. Therefore, continuous validation and monitoring are absolutely essential.
So the governance needs to keep pace.
Yes.
Mhm.
Similarly, the risk management process itself is not static. It requires ongoing risk assessment, regular updates to the risk treatment plans based on monitoring results, and reevaluation based on feedback, incidents, or new information. Those AI system impact assessments we talked about, they should be revisited at planned intervals and also whenever significant changes are made to the AI system or its intended use.
Keep checking the impact.
Right. And of course, the actual performance of the AI system needs to be continuously monitored, measured, analyzed, and evaluated against the defined requirements and objectives, as clearly outlined in ISO-IF FTIS 42001.
So it's really not a set it and forget it situation at all. AI governance demands continuous attention, adaptation, and resources.
Exactly. It's a dynamic and evolving process that needs to adapt alongside the AI system itself and the ever-changing context, technical, social, regulatory in which it operates.
Wow. This has been an incredibly valuable deep dive. It really clarifies what AI governance is all about, the scope, the necessity, the practicalities, and why it's so important in today's world. Much clearer than just reading headlines.
That was our aim to provide you, the listener, with a clear understanding of the why, what, how, who, and when of AI governance, grounded in the principles and techniques outlined in these crucial, though often dense, international standards.
So just to quickly summarize for everyone listening, AI governance is essential for building trustworthy and responsible AI systems by proactively managing the unique risks they present. That's the why. It encompasses a framework of standards and practices, including powerful V&V techniques like formal methods, simulation, and evaluation. That's the what.
Right.
It's implemented through systematic risk management processes, organizational AI policies, impact assessments focused on people, and specific technical methods. That's the how. It requires the active involvement of all AI stakeholders with really strong leadership and commitment from the top. That's the who.
Crucial.
And importantly, it must be applied continuously throughout the entire AI system lifecycle, from the initial concept right through to ongoing operation and monitoring. That's the when.
A perfect distillation of our discussion. Couldn't have said it better myself.
So here's something maybe to think about as we wrap up. Consider how these principles of AI governance, risk assessment, validation, fairness considerations, transparency efforts might already be subtly influencing the AI-powered technologies you interact with every single day, even if you're not consciously aware of it. Think about the apps on your phone, the recommendations you get, maybe even sisters at your workplace.
That's a great point. It's often working behind the scenes.
Right. And what new questions does this understanding raise for you about the future of AI regulation, about its broader impact on society? What should the priorities be? You might even be intrigued now to maybe explore some of these international standards we mentioned in more detail if you really want to get into the weeds, to gain an even deeper appreciation for the complex work that's going into shaping the responsible future of AI.
There's certainly plenty to explore.
Absolutely. Thanks for joining us on this deep dive into AI governance.